Hey everyone, since receiving my RTX 5080 a few weeks ago, I've mainly been happily gaming on it, but of course I've been looking at all the melting stories with some concern. And yes, they mainly affected the RTX 5090s and also the 4090s, but the RTX 4080 and 5080 have been affected too. And I wasn't really going to do this video because I'm not into scare bait or sort of propagating that. That's not who I am or what this channel is about. But actually I've started seeing people on Reddit say, I've just finished my new build, but I'm too scared to turn it on in case things melt. And I totally understand that sentiment, but obviously there are things you can do to try and reduce the chances of things melting, which I wanted to talk about in this video, along with some do's and don'ts, because actually feeling your cables every so often, or if you've got a thermal camera, inspecting your cables with that is a good thing. What you shouldn't do is actually get your cable and constantly unplug it and look for damage and then plug it back in, because the actual 12 volt power connector is only rated for 30 mating cycles. You know, you can look at the cable once or twice to inspect it, but certainly don't, take it out and back in every week or every month, because you could end up damaging things. But that's why I wanted to do this video and just talk through the do's and don'ts really. But firstly, I wanted to briefly recap some history, just for 1 minute. I'm not going to give you a history lesson on electricity or something, but basically the 40 series came out, and very quickly we've seen stories about melting 4090s, in some cases 4080s, and mainly they were melting at the GPU side, either on the connector that goes into the GPU or the actual cable end, but obviously sometimes we've seen it at the PSU side as well. And basically a lot of the internet community concluded at first it was user error, with people not plugging the cable all the way in, or maybe they were using loads of adapters and things like that. But as time has gone on, and since this issue hasn't been fixed with the 50 series, we see more and more research from Buildside and Bauer that actually show that, just generally speaking, the PCB design of the RTX 5090 and 5080 just isn't very good, because all of the 12 volt wire cables come in and then they're effectively put in the same blob. There can be no load balancing of the wires, and so you could have all of the 600 watts, in the case of the RTX 5090, flowing through one or two cables if something was to go wrong with the cable, and then that's going to lead to melting and things like that, or it could lead to melting. And the RTX 5080 isn't as bad because it uses around 350 to 380 watts of power at max, but that is still borderline. Like on Reddit, an electrical engineer that works at Intel did actually say that that's completely borderline even for the RTX 5080, because there's just not enough safety headroom in the actual 12 volt power cable and connectors and things like that, which kind of is worrying, because it's not like Nvidia can just push out a software update that just magically fixes this for all of their cards. But what can we do to actually protect ourselves as best as possible? Well, let's take a look. So first thing you should do is make sure you're not mixing and matching loads of different cables. And I know I said at the start of this video that, it's not really a user error sort of thing, because people haven't really had issues with the 8-pin connector, so I don't think we should really be blaming people for user error anymore, because this is an Nvidia design problem. But if you do have something like this, and I'm not hating on this particular person, but if you've got some setup like this, then I would just make sure you don't do that. And in this particular case, this person actually had this for their previous card and it worked absolutely fine, and they just forgot about it, and then they used it for the RTX 5090 FE, and obviously it didn't really work. And in this case, they mix in Corsair and EVGA cables with loads of different adapters, and something like that is never going to be a good idea. Mainly speaking, you should keep things simple and have as little connections as possible. Either get a power supply unit with a native 12 volt 2x6 slot, and we'll talk about that later because that's not some magic panacea that's going to fix everything, or you should use the actual adapter that comes in your RTX 5080 or 5090 box, because it's actually pretty good. It's got the 12 volt power cable on one end, and then you plug the 8-pin PCI Express cables in there, and as we know, the actual 8-pin design is a lot better and it's got more safety headroom than a native 12 volt 2x6 connector and cable, so we'll talk about that later. But actually using the PSU cable or using the included adapter is probably going to be safer than doing something like that. And again, I'm not trying to hate on that person, but if you've got some slightly janky power setup and you forgot about it, just make sure you review it. So that's the first thing I would say. The second thing I would say is that the actual 12 volt 2x6 cables are only rated for 30 mating cycles, and this is the same as the 8-pin one, but there's more safety headroom, so that's why that hasn't caused as many issues. But basically the cable that we've got here, so the 12 volt one, that's only rated for 30 mating cycles in general, meaning if you plug it in and take it back out and inspect it, and you keep doing that a lot, you can actually end up damaging the actual plastic or the pins inside of it and degrade it to a point where actually things can melt. People are actually calling it the Schrodinger's cable or Schrodinger's connector on Reddit, because actually it could be working fine, and then you take it out and look at it and it's still fine, and then when you plug it in, you've plugged it back in a slightly incorrect way, and then it melts, and it's completely worrying. And again, it's awful that we're actually in this position that we need to be worried about things like that. But actually, There's a bit of a debate about it because the Cultist Network do actually have another blog, and I'll link to all of this down in the description, but they quote this 30, connection, disconnection rating and actually say this is very conservative, and in general, it's unlikely you're actually going to have major issues the moment you hit that 30 limit. But actually, I just wanted to raise this point because while there's debate about it, the official advice in general for most PSU makers is that 30 is the limit. So that is something worth knowing. And actually, what some people have found is they had variable voltage on the wires, but then by reseating things, it actually resulted in much better results. So the voltage was much more stable, or the amperage was much more stable on all of the pins. And that's kind of interesting because if you are monitoring things in HWInfo, as I'll talk about later, then you see some issues that actually disconnecting and reconnecting, in other words, reseating the cable can actually help you quite a lot. But just don't do it too often, and don't get into a habit of actually inspecting your cables, once a week, because that probably would be too much. The third thing I wanted to cover is to be careful with overclocks, and obviously, many board partners actually have overclocked variants. I'm not saying you shouldn't buy them or something like that, but just in general, and I know we all know this, but it's worth saying, the more you overclock it, the more the power usage will be. And actually, for this particular card, this person ended up getting around 575 watts of power out of their 5090, and actually Linus Tech Tips in a recent video where they were looking at 8K gaming, they were seeing 605 watts actually at peak through their Supreme Liquid graphics card, which is quite a lot, considering that the 12-volt cable is only rated for up to 600 watts. So again, there's not much safety headroom here, and if you're exceeding the actual wattage or coming close to it, then that is really concerning. So again, I'm not saying don't overclock things, because obviously that's part of the fun of things, and you should be able to, have a graphics card and experiment with it. But if you run in loads of experimental overclocks and pushing things loads and getting power draw that's completely exceeding the cable, that could be a risk factor, which either means you then need to not do that as much, or you keep doing it, keep having lots of overclocks, but then monitor things more. And my next few tips in a minute will actually cover how you can monitor things. We'll look at that in a minute. I'm not saying just don't do anything. But my fourth tip is to actually consider getting a 12-volt 2x6 power supply unit, also called an RTX 3.1 power supply unit. And I've got a couple of them lying around. I've got one from Corsair and I've got another one from Montech. They both RTX 3.1. And basically they have native 12-volt 2x6 slots on the power supply unit. You plug a single cable in there and then a single cable into your graphics card. And in general, there's less things to go wrong. Remember in that first example where somebody had loads of different points of failure, you're not going to have that as much if you've got an RTX 3.1 power supply unit with that native 12-volt 2x6 slot. But actually it is worth pointing out that, an RTX 3.1 power supply unit won't magically, fix this fundamental issue with how NVIDIA have actually designed their boards to actually put all of the power going into the same blob, as Buildzoid calls it in his brilliant video, which I'll link to in the description. In other words, just buying one of these isn't going to suddenly mean that your RTX 5090 runs with no issue whatsoever. But it is worth pointing out that the actual cable itself hasn't changed, and this infographic says that too. This is still a 12-volt power cable, or it's not because this is the adapter, but if you actually had that cable, that actually hasn't changed. What has actually changed with RTX 3.1 is the female connector. So on the PSU side and also the graphics card side, they're now slightly safer because of how the sensing pins and conductors have changed. The next thing I wanted to talk about is, as DeBauer's videos have actually shown, when there's a problem with the cable or the connector or whatever else, what can actually happen is all the voltage can end up flowing through like one or two of these wires, and then bad things can happen. You can have melting and things, and actually DeBauer in his video, which I'll link to in the description as well, you can see the thermal camera that actually shows that a lot of the power is flowing through one or two of the cables, but that's where melting can actually happen. So if you've got a cable like this, where it's not bundled in one big thing, but it's actually, you've got the individual wires, what you can actually do every so often is just go inside your computer while it's running and you're gaming or running Thermark or whatever. You can actually feel the cables, and if one or two of them are much, much warmer than the rest, that could actually be a really bad thing. But obviously that doesn't work too well if you've got one of the bundled cables with a sheathing, because it's much harder to actually see everything. In that case, what you can either do is sometimes you might be able to feel just around the very tip of the cable where it goes into the graphics card unit, or maybe you can look at actually changing the cable completely if you're able to buy one from your PSU maker, so it does have the actual braided cables, because then you can feel the cables individually and that can be better, or you can then inspect it better with a thermal camera. The next thing you can actually do, and it's quite a cool tip actually, is that some motherboards come with Thermistors, so basically little cables or connectors that actually report into the motherboard for a particular temperature. And what this particular person has done on Reddit is actually wrap that around the GPU and the PSU side connectors of the 12-volt power cable, and then they set up an alarm to say if things get too hot, then actually alarm me or shut down the system or things like that. And actually you do tend to get them in more expensive motherboards, so not so much with the B ones but with the X ones, and this user has said the ASRock X870E Tachi has actually got that. They got 3 of them, so they can actually use those thermistors, wrapping them around certain cables and put them on certain points, and actually they're able to monitor the voltage and the cables that way, and that's actually a really good idea. The next thing you can do is actually power limit things within the NVIDIA apps. You could go over to the System tab, and then you could go over to Performance, and in there you've got the power maximum. And by default it starts off at 100. You can actually lower that. Or you could, when it doesn't keep saying there's a problem, try again later. I need to reinstall this, it's a bit buggy at the moment. But what some people have actually done is run this system at like 84 or 90 or whatever the actual level might be. That actually doesn't result in too much performance drop off, because that can actually make a big difference to how much wattage is actually flowing down these wires. But it is worth pointing out that while power limiting can be a good thing, other people prefer undervolting, because actually undervolting is better for everything. It brings down power usage in general, and it's going to place less load on the cables in general, whereas simply power limiting within the NVIDIA app, for example, all that's going to do is bring down that final value. The next thing you can do is actually open up HWInfo, and you can use that to actually track your voltages and things like that. So if we just open that up, we go to the sensors mode. And what some people have been doing is keeping an eye on this one, the GPU PCIe plus 12 input voltage, which on my system right now is reading at 12.152 volts. And obviously, you might know this already, but this is a 12-volt cable or connector or whatever. So ideally you want to be around 12 volts. But actually it's not quite as simple as that, because there's going to be variance, and when the actual system usage is increasing, when gaming or running Thermark, you're actually going to see that voltage drop a little bit. That's just how things work, that's completely normal. But what you really got to do is get used to how much your voltage drops and see what is normal for you. Some people argue this isn't too useful, because if it drops down to like 11 volts, that's probably a sign that damage has been done and you've got burning or something like that. But other people feel, a bit reassured knowing that they can actually go into HWInfo and actually keep an eye on this particular value. The next thing you can do is actually use a thermal camera, and obviously that's what DeBauer has done and other people. I've got one here, and actually a thermal camera can be a really good tool for actually inspecting the voltage that's actually running through your wires. It's not going to show you the exact current, but it will show you if 1 or 2 of your cables are actually getting abnormally warmer than the rest, so that is something that's worth knowing. And obviously I put some examples on screen now of actually me using this camera with my specific setup. And obviously I know I got an RTX 5080 and I've power limited it, so it's unlikely that I'm actually going to have this melting issue. But if you have a thermal camera lying around, that can be a good thing to do. It might not be worth running out and buying one of these, especially the more expensive models if you don't already have one, because simply touching the cables and seeing if any are too hot to touch is probably a cheaper and safer way of doing things, in my opinion. Or not necessarily safer, but certainly a cheaper way of doing things. But actually getting a thermal camera can help you if you are really concerned. And sometimes what you might find is going at the back of the computer and inspecting them at the PSU side might be better, because you might have more access there and there might be less cable management there. It might be easier to actually get the wires apart and things like that. Another thing you can do is actually get a cable clamp, so a DC voltage cable clamp that you can see here the HWInfo is using. And what that can actually do is you can put it around each individual wire, and it'll actually read the amperage of that particular wire. And what HWInfo has actually found is there's significant variance with certain cables and things like that, and that is part of the problem, because if you've got one wire actually only having 6.2 amps and then another cable at like 12.1, then that obviously is quite a bad thing, or could be a bad thing, because it's showing that there's those voltage differentials. And again, then you might be looking at needing to reseat the cable, or and then checking the pins to see if any are overly recessed or things like that, because that could be a problem. The last thing I wanted to cover is potentially look at actually changing your cable every so often, and this one again is a little bit controversial, but what some people are finding is that the cable might degrade over time, like we've discussed, either due to unplugging it and inspecting it and putting it back in, or due to something called oxidation. So what some people do is maybe change the cables every year or every 2 years, which I don't know, it's up to you whether you think that's a good idea, but some people have actually done that, so I just wanted to flag up that particular option. I mean, you'd like to think that in theory, if you've, mitigated things maybe via a small power limit, and maybe you've kept an eye on things via HWInfo, you shouldn't also need to change your cable every so often. but that is something you could do. And that pretty much wraps up these tips. It's really frustrating that NVIDIA haven't learned lessons really from the 40 series. They've come up with a 50 series design that, you know, puts all the power onto the same blob, as BuildZoid's excellent video actually showing off. And really, none of this is user error, even in the case that I looked at first, which isn't exactly ideal. You know, really, well, maybe you don't want to do that. In general, you know, it really sucks that we're in a position where we're buying really expensive graphics cards and then having to worry about things like this. But what I would say is, we don't know the failure rate of any of these, you know, cards or connectors or anything like that. It could be that less than 1% or less than 0.1% are actually failing. And what I would say is just try and enjoy your card. We've got good cards, so let's try and enjoy them as best as we can. But also do some common sense things like looking at HWInfo for the input voltage and feeling your wires every so often and things like that. And I hope this video has given you some level of reassurance. If you've got any other questions or doubts though, please let me know down in the comments. And other than that, if you enjoyed this video, please click the thumbs up button and please subscribe to see more videos like this. Thanks for watching.